The next book I want to talk about is Mathematical Foundations of Quantum Mechanics by Mackey. As the book says, the book is about the mathematics of quantum mechanics, and it is a fairly rigorous book on the mathematics. It deals with quantum mechanics, it deals with the group theory behind quantum mechanics, and it applies that to the different quantum mechanical sets. As you see, the book deals with fairly advanced view of physics. This is not an introduction to quantum mechanics. It is also not an introduction to the mathematics. You really need to know both very well. You need to be very comfortable with quantum mechanics. Here you see Hamiltonian mechanics. So the classical mechanics is taken for granted, you know this. The quantum mechanics is taken for granted that you know it. And also the mathematics is granted that you know it. And it tries to relate it to. So it shows you how the mathematics of group theory or function analysis is basically used in quantum mechanics. Here we see, for example, logic. We see quantum logic. And it shows how certain lattices are dealt with in logic to get a logic for quantum mechanics. And that's like very typical for a book on mathematics of quantum mechanics. The book is very advanced, but very nice. It contains a lot of gems. It is a very old book, as you can see from the typesetting. It doesn't really use LaTeX even. And I'm not sure if a LaTeX version exists. But I think there are better books nowadays than this one. I think this is a fairly old book, and newer books that have the same topics are there and should be used instead, I think. Next, we see here General Chemistry by Linus Pauling. Niels Pauling, very famous chemist. And it's a very, 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 very thick book, right? Let me see how many pages it has. It has like 1,000 pages on chemistry. And the book is meant to be an introductory book to chemistry. I think Pauling didn't really intend anybody to know any chemistry going in. And yeah, he really starts from scratch. He starts from nature and properties of matter and then goes on to studying atoms and electrons. Later on, it goes into chemical bond. It goes into gases, gas theory. It goes into thermodynamics. It goes into rates. So it basically teaches a lot of chemistry. It's a nicely written book. It's a favorite of many people into chemistry. If you go online and you're searching in Reddit for an advanced book on chemistry, from a chemist point of view, this is the book you often get, right? So if you don't want to study like the silly introductions and want a mature introduction, this is really the book you want. I personally did not like the book very much. I think the exercises at the end of the chapter were a bit confusing. I did not like them. And yeah, the explanations could be, I get, a bit more systematic. I get what the author was trying to do, but yeah, it's not my style. Maybe I'm just not a chemist. Here we see a non-science book. We see a book on the Glorious Cause, which is a book on the American Revolutionary War. And the book deals basically with the Revolutionary War. And it starts from British America and it goes... Oh, that's maps. Yeah, so it starts with British America and what the British did. It goes to the different kind of crises. It goes to the war, finally independence, and until independence happened, and until the ratification of the Constitution. It's a very scholarly book, I think. I think it was a nice read, even though I didn't read it completely, but it was also a very hard read, especially as a non-American who has like no real good idea of what happened. Like, I don't know any of the famous stories that are so prevalent in the American classes about whatever. I just know the very basics, and then I think this book was maybe a bit too hard for somebody with doesn't have that cultural background, I guess. Here we come to one of my absolute favorite linear algebra books by Meyer, Matrix Analysis and Applied Linear Algebra. Why do I like it so much? Because it has some excellent explanations. The book teaches, like, if you check the usual introductory linear algebra books, they can be subdivided in two classes. Either have the mathematical ones, take Exler and Friedberg. Well, they should not really be introductory, but that's what they often use that. And they start right away from vector spaces. Maybe a little bit of motivation on why the axioms are true, but they start right away from vector spaces. And then we have other books which only do matrices, and maybe at the end they touch vector space a little bit and touch a little bit on the generalization that's possible. I think both books are inappropriate for the beginner. I think matrices are easy to follow, but they're boring and they kind of obscure the facts that are in linear algebra. And the books like Exler and Friedberg are just too hard for the beginner. This book takes the first approach, where he starts from matrix algebra. It does matrices first, but he gets to vector spaces quite relatively early. And basically, for the rest of the book, he covers orthogonality, determinants, eigenvalues, and at the end, there's a chapter on the parent-Frobenius theory. Why do I like this book? Because the book contains a lot of material, but does so from a very applied point of view, and does so from a point of view that you're interested in also working out actual problems. And with actual problems, I don't mean solve this system without any relevance to what you're doing. No, actual problems in engineering and physics and economics and whatever. So, for example, one of the things I really like, here you see a thing about floating point numbers, which you never really see in books of that kind. But one example is where he discusses systems that are ill-conditioned very early on. So here we see a system, and the system is given by a system of equations, and the system of equations is given by decimals. And the idea is that you disturb one of the decimals, you just make an error in the measurement, or an error in the numerical code, or just a rounding error. And what he discusses then is that by making a very simple and a very small error, the system solutions can change wildly. And the solutions you get by making that error, by making an error in the coefficients, you can make this way an error that is giant in terms of the solutions. He discusses this very nicely. And here you see the geometrical side of this, where you have the original solution, and then you perturb the lines, and you get a solution that is in a very different place. And he discusses that geometrically, and he just discusses that, in depth, really, in the very first chapter. So this is not something that you will see introductory linear algebra books do at all. Neither the mathematical kind or the non-mathematical kind. They just don't do that. They just don't concern themselves with this. While Meyer does these kind of things. It really talks about the applications from a very nice point of view. Here we see an entire section on electrical circuits and how it is used, and he has many other applications of this. One can say, perhaps, that the theory is a bit dry, but I think that a theory of linear algebra is always dry. I think linear algebra is just a boring theory to begin with. And if you really are interested in applying linear algebra to any specialized case, I really think you need to read this book. It's one of my absolute favorites. It's very, very, very nice. Very, very nicely written. Yeah. Then I want to talk about this book by Gerd Group, Distribution and Operators, which is a book on function analysis, and function analysis from the point of view of generalized functions. So here we see the contents, and it starts right away with function spaces, and it goes towards distributions. You see it discusses Sobolev spaces. It goes straight to pseudo-differential operators, boundary value problems, and all kinds of applications in Hilbert spaces. As you can see from the topic list, this is a graduate book. You are expected to know function analysis quite well already. This book absolutely takes no prisoners. It's a fairly difficult book, and you really should know your stuff before you even touch this. But yeah, I think I'm very interested in generalized functions. So this book was really a book I had to have, because yeah, it's just a very beautiful theory, and this really shows the mathematical version of it. There are many undergrad books on this topic, and they kind of skirt around the mathematics. Like everything is maybe done rigorously, like Jones' book does everything rigorously, or Hoskins' book kind of does everything rigorously, but not really. But it doesn't really touch on the more advanced topics like the topology or the Hilbert spaces. It doesn't really talk about that too much, or even measure theory for that matter. This book does, and it does everything really right. There are many books like this out there which does everything right. The book of Gelfand comes to mind, but I think this one is quite modern, and I think quite very nice. The final book I want to talk about is this book by Lavendom, Basic Concepts of Synthetic Differential Geometry. Synthetic differential geometry is basic differential geometry, dealt with in a very different way, dealt with the concept of infinitesimals. This is not a physics book. This is not a non-rigorous book. This is a very, very rigorous book. It maybe it's even beyond grad level. Like here in the final chapter, it talks about Topos theory, and talks about some heavy category theory. So you are expected already to know this material, and to be really comfortable with non-standard analysis, to be really comfortable with logic. And if you do an abstract algebra, here you see quotients, you see spectrum even, so it's algebraic geometry. You use a lot of very niche techniques to really give a different background on differential geometry. A background that is usually not covered at all. I like this approach. I'm very interested in this approach, but I'm not sure I like the book that much. If you really are interested in this topic, and then this is not a good book because it's not introductory. It already starts fairly advanced. I think there are better books out there for initial readers. Bell's books come to mind, the book by Bell, the famous logician. If you want more after Bell is the book, then maybe this book would be good. But yeah, what does this book cover? So it covers differential geometry with infinitesimals. So basically you want to remove the usual analysis, you want to remove epsilon deltas, and you want to frame things in terms of infinitesimals. It offers a very nice point of view, maybe a more intuitive point of view that maybe the standard Lie version of differential geometry does not give. So I do like looking into it, but yeah, maybe not with this book.